Have you ever wondered if there were no power cuts, ample amount of energy without ever harming the environment, and we could generate lots of energy and move anywhere in the universe? You might think I'm crazy or delusional. But my friends, it might be possible and it's currently in the works. So let's explore this technology and find the answers to our mystifying questions. Shall we? So, welcome to our deep dive into the world of nuclear fusion. Today we are exploring why this cutting-edge technology is hailed as the future of sustainable energy. What is nuclear fusion? To understand nuclear fusion, let's start with the basics. Nuclear fusion is a process where two light atomic nuclei combine to form a heavier nucleus, releasing a massive amount of energy in the process. This is the same reaction that powers our sun and other stars in the universe. In the core of the sun, hydrogen atoms are continuously fusing to form helium, releasing energy in the form of light and heat. Here on Earth, scientists are working tirelessly to replicate this process. But what makes nuclear fusion so special? Fusion is fundamentally different from nuclear fission, the process currently used in nuclear power plants. While fusion involves splitting heavy atomic nuclei like uranium, fusion merges light nuclei like hydrogen isotopes. This difference has profound implications for energy production and safety. Why fusion is a game changer? First, nuclear fusion produces an immense amount of energy. Just a small amount of fusion fuel can produce energy comparable to burning tons of coal or oil. This means fusion has the potential to meet our energy demands with much less fuel. Second, fusion is incredibly clean. Unlike fossil fuels, fusion doesn't produce harmful emissions like carbon dioxide, which contributes to climate change. And unlike nuclear fusion, it doesn't produce long-lived radioactive wastes. Third, fusion is virtually limitless. The primary fuel for fusion is deuterium, which can be extracted from water, and tritium, which can be bred from lithium. The Earth's ocean alone holds enough deuterium to power humanity for millions of years. Lastly, fusion is safe. The conditions required for fusion are so extreme that if a reactor were to fail, the reaction would simply stop, avoiding the risk of a catastrophic meltdown. Sounds amazing, right? But if it's so great, why aren't we using it already? The challenges of nuclear fusion. The journey to achieving practical nuclear fusion energy has been long and challenging. One of our biggest hurdles is the extreme condition needed for fusion to occur. We are talking about temperatures over 100 degrees Celsius. That's hotter than the core of the sun. Creating and maintaining such temperatures require advanced technology and a lot of energy. Another challenge is achieving a net positive energy output. We need to get more energy out of the reaction than we put in, and that's no small feat. Containing the hot plasma, the state of matter where fusion occurs, is also incredibly difficult. Scientists used powerful magnetic fields to contain the plasma, but keeping it stable for over long periods is a major technological challenge. But despite these challenges, significant progress is being made around the world. Let's take a closer look at some of the groundbreaking projects leading the charge. Major fusion projects and breakthroughs. One of the most ambitious fusion projects is ITER, the International Thermonuclear Experimental Reactor, being built in France. ITER is a collaboration between 35 countries and aims to demonstrate the feasibility of fusion as a large-scale and carbon-free source of energy. ITER will be the world's largest tokamak, a device that uses magnetic fields to contain and control the hot plasma. It is designed to produce 500 megawatts of fusion power, which is 10 times the energy required to heat the plasma. Then there is the National Ignition Facility (NIF) in the United States, which uses powerful lasers to achieve fusion. The NIF focuses 192 laser beams on a tiny pellet of fusion fuel, creating the extreme condition needed for fusion. And let's not forget about the private companies like Tokamak Energies and Commonwealth Fusion Systems, which are developing innovative approaches to make fusion more efficient and commercially viable. With each breakthrough, we are getting closer to making fusion a reality. But how will this impact our future? The future of fusion energy. Imagine a world where our energy is clean, limitless, and safe. With nuclear fusion, this vision could become a reality. Fusion power plants could become a steady supply of electricity without the environmental impact on fossil fuels or the long-term waste of nuclear fission. Fusion could revolutionize how we power our cities, industries, and even transport systems. It could drastically reduce our reliance on finite resources and help combat climate change by cutting greenhouse gas emissions. Moreover, the development of fusion technology can spur economic growth, creating new industries and job opportunities. The race to achieve fusion is also fostering international collaborations, uniting countries in the common goal of sustainable energy. However, for fusion to fulfill its promise, continued investment in research and development is crucial. Governments, private companies, and the public needs to support these efforts to overcome the remaining challenges. So what can you do? Stay informed, support policies that fund fusion research, and advocate for clean energy solutions. Together, we can make the dream of fusion energy a reality. Let's take a closer look at ITER, the largest and the most advanced fusion project till date. ITER stands for International Thermonuclear Experimental Reactor, and it's an unprecedented international collaboration aimed at providing the feasibility for fusion power. ITER's tokamak, the core of the reactor, uses powerful magnetic fields to confine and stabilize the hot plasma. The tokamak is essentially a donut-shaped vacuum chamber surrounded by superconducting magnets. The magnetic fields are created by a combination of external magnetic coils and the current driven through the plasma itself. This creates a magnetic cage that keeps the plasma away from the reactor walls, allowing it to reach the extreme temperature needed for fusion. One of ITER's primary goals is to achieve a plasma pulse of at least 500 megawatts of fusion power for 500 seconds. This will demonstrate that fusion can produce more energy than it consumes, paving the way for future commercial fusion reactors. ITER also aims to explore advanced fusion fuel cycles, including the use of deuterium and tritium, which are more efficient than using only deuterium. This will help optimize future reactors for better performance and sustainability. The insight gained from ITER will be crucial for the next generation of fusion reactors, which could become the backbone of our energy infrastructure in the later half of the 21st century. Laser-based fusion and the NIF. While ITER focuses on magnetic confinement, the National Ignition Facility (NIF) in the United States is pioneering laser-based fusion. The NIF uses intense laser beams to compress and heat tiny fuel pellets to the point of fusion. The NIF's approach is called inertial confinement fusion. It involves firing 192 laser beams at a small pellet containing deuterium and tritium. The lasers heat and compress the fuel to extreme conditions, initiating fusion reactions. One of the NIF's significant achievement was reaching the threshold of ignition, where the energy produced by fusion reactions equals the energy delivered by the lasers. This milestone brings us closer to a practical fusion power plant. The NIF also conducts experiments that provide valuable data for both fusion energy research and nuclear weapons science, ensuring the safety and reliability of nuclear stockpiles without the need for underground testing. The data from NIF's experiments are crucial for developing future laser-based fusion power plants, which could complement magnetic confinement reactors like ITER, providing diverse and robust fusion energy solutions. Private sector innovations in fusion energy. Beyond large international projects like ITER and NIF, the private sector is also making significant strides in fusion energy. Companies like Tokamak Energies and Commonwealth Fusion Systems are leveraging innovative technologies to accelerate the development of practical fusion reactors. Societal and economic impact of fusion energy. The successful development and deployment of fusion energy will have profound impacts on society and the global economy. Fusion power plants could provide a stable and continuous source of electricity, reducing our dependence on fossil fuels and mitigating the effects of climate change. Fusion energy will also enhance energy security by providing a reliable and abundant energy source that is not subject to geopolitical and supply risk associated with fossil fuels. Countries around the world will benefit from greater energy independence. Economically, the fusion energy industry will create millions of jobs in research, engineering, constructions, and maintenance. The development of fusion technology will spur innovations in other fields such as material science, superconductivity, and plasma physics. Fusion power could also drive down electricity costs in long term, making energy more affordable for consumers and businesses. This would have a cascading effect on the economy, boosting productivity and growth across various sectors. Furthermore, fusion's clean energy could improve public health by reducing air pollution, which is linked to respiratory and cardiovascular diseases. The societal benefit of cleaner air and a healthier population cannot be overstated. The transition to fusion energy will require significant investment and international cooperation, but the rewards, a sustainable, prosperous, and healthy future, make it a journey worth embarking on. Call to action and conclusion. Nuclear fusion holds the key to a sustainable, energy-rich future. While challenges remain, the progress made so far is incredibly promising. With continued effort and innovation, we can harness the power of stars to meet our energy needs here on our Earth. As we move forward, it's crucial that we support policies and initiatives that fund fusion research and development. We need to foster public and private sector collaborations to overcome the remaining technological challenges and bring fusion energy to market. Stay informed about the latest developments in fusion technology and advocate for sustainable solutions in our community. Together we can make the dream of fusion energy a reality. Thank you for joining us on this exciting journey into the world of nuclear fusion. Don't forget to like, subscribe, and hit the bell icon to stay updated with our latest videos. Together we look forward to a brighter, cleaner future. Until then, keep learning, keep exploring, and be curious. Thank you.